Hello and welcome to my Algebra 1 review series. This video covers Chapter 9, Section 7, titled Factoring Special Cases. By the end of this video, you will have reviewed past lessons describing the methods of factoring perfect square trinomials. You will review factoring a perfect square trinomial with the a term equal to 1 and with the a term not equal to 1. You will review the difference of squares. This review will include the difference of two squares for a equal 1 and a not equal to 1. Additionally, you will factor out common factor before factoring your trinomial. If you'd like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to this channel if you find this video to be helpful. Thank you. Okay, so I'm going to start off this review with a definition. A perfect square trinomial. Any trinomial of the form ax plus 2ab plus, I said a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared, is a perfect square trinomial. Perfect square trinomials can be factored into identical binomial factors. Objective 1a. There's two slides to this objective description. Factoring perfect square trinomials. In lesson 9-4, you found the square of a binomial. Today we'll look at a plus b squared and a minus b squared. A plus b squared equals a plus b times a plus b, or a squared plus 2ab plus b squared. And a minus b squared is equal to a minus b times a minus b. So these are squared. It's a minus b. You have it twice. You're multiplying it twice. Is equal to a squared minus 2ab plus b squared. Any trinomial of the form a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. That's the difference here. We have the plus. Right here we have a plus, and here we have the minus. That's the only difference in what I just read there. Is a perfect square trinomial. Perfect square trinomials can be factored into identical binomial factors. Okay, here's a rule that we're going to look at here. It says the perfect square trinomials. For every real number a and b, every real number a and b, a squared plus 2ab plus b squared is equal to the quantity a plus b times the quantity a plus b is equal to the quantity a plus b squared. Well, you can see that because this is no more than a plus b times a plus b, which is a plus b squared. And we'll look at the negative version. A squared minus 2ab plus b squared is equal to a minus b times a minus b, or we could rewrite it as a minus b squared. Examples of this could be like x squared plus 10x plus 25, where x plus 5 and x plus 5 is equal to x plus 5 squared. Okay, or we could say x squared minus 10x plus 25. And we could say here that the quantity x minus 5 times the quantity x minus 5 is equal to x minus 5 squared. And when you multiply these back, you see that it's the same term. This x minus, in this case, the lower one here, x squared minus 10x plus 25. You can get that same thing back by multiplying. X times x is x squared. X times negative 5 minus x times 5x. It's going to give you minus 10x. And then finally we have minus 5 times minus 5 is positive 25. So it's exactly what we're looking at, okay? So taking this objective a little further, objective 1b, the second slide, you can factor a perfect square trinomial using the method shown in the previous lesson. Or you can recognize a perfect square trinomial and then factor it quickly. That's if you can look and say, oh, that's a perfect square trinomial. Then you can do it without going through a lot of steps. Here's how to recognize a perfect square trinomial. First, the first and the last terms are both can be written as the product of two identical factors. Okay? And secondly here, the middle term is twice the product of the factors from the first terms and one from the factor from the last term. We're going to see what that really means here. Consider the following trinomials. 4x squared. Okay? This is the whole thing here is the trinomial from here to here. We're looking at the whole trinomial. And the first one is broken into 4x squared, which is 2x times 2x. Because the 2 and the 2 multiply, we get the 4, and the x's multiply, we get this x squared. Okay? Then the middle term, plus 12x, can be broken down into, and they said, remember, it was 2ab. So you can, if you can factor a 2 out of here, you can say, okay, I've got the 2 out, so now that gives me a 6x. And I can factor the 6 into a 2 and a 3, so it's a 2x times 3, which will give us the 12x that we're looking for. And then finally, we have the last term is a 9, the square root of 9, which is 3 times 3. Well, here's one of these is x squared, is 2x, and the other term from the first and last terms is a 3. And if you look in here, it's the quantity 2ab. Well, here's the 2, here's the a, we got it from the a right here, and here's the 3, we got that from the b, from the 9. So one of the terms from the a and one of the terms from the c term, we multiply them together, and both of them times 2. That's how we get this. This is a perfect square trinomial. In its factored form, it looks like this. So 2x plus 3 times 2x plus 3 is equal to 2x plus 3 squared. And if we look at the second version of this, the same 2x squared is right here, and the same 9 is down here, but now we have a positive 20 instead of a positive 12. Well, we're going to take and factor out the 2, so then it's going to give us a 10. And can the 10 give us a 2x and a 3? The 3 and the... No, it cannot. It's not going to give us... It's going to give us what? It's going to give us a different value. We have a 10 that we have to factor, not a 6 that we're going to factor. So this is not a perfect square trinomial. Factor by listing factors as shown in the previous section. So you're going to go factor this by the way we did in the previous section, or previous lesson, if you will. Okay, so another method of factoring is what they're saying. When you factor a perfect square trinomial, it may help to write the first and last terms as the products of identical factors. That's kind of what we're doing here by breaking it apart. Okay, so we'll see more of that as we move forward. Okay, example 1, factoring a perfect square trinomial with a equal to 1. So let's take a look at this. It says factor x squared, well, that's with the a term equal to 1, x squared, minus 8x plus 16. So if we go ahead and proceed, we're going to say x squared minus 8x plus 16. We're going to break the first and last term down into its identical terms, right? So in this case, it's x squared, so we have x times x. In the last case, it's 16, so we have 4 times 4. These are the square root of 16 and the square root of x squared, right? So now we have, our terms are broken down into x times x minus 8x and plus 4 times 4. Then we go to the next line here. We say, well, we have the x times x, which is fine. Then we say, out of this 8, can we factor out the 2? Because it needs to be a 2ab. Well, if you factor out a 2, you're going to be left with a 4, right? And if you factor out that 4 can be broken into what? The 4 can be broken into a 1 and a 4, and we have a 4 here, see? So, and the 8 it's got the 2 removed from it, so that's where the 4 is, and then we have an x. So we're going to say we have 1 of the x, here's the 8x, here's the x, 1 of the x terms, and then we're going to have the 4 term right here. So there's 2 4s from the 16. We're going to use one of them because it says 2ab, not 2a squared b squared. It's 2a, a is the x, b is the 4. See it right here. Does the middle term 2ab, is it equal to that? X, 8x is equal to 2 times 4, x times 4. Okay? So now, since we've done this and we can break it this way, we can now write the term as x minus 4, okay, x minus 4 squared. And we're done. That's factored. We factored it completely. It's a perfect square trinomial. So let's go look at a few of them. Okay, example 1, check your understanding. As you know, you're going to do these on your own. I hope you will anyway. I pause the video, work them out. When you come back, we'll do them together. It says factor each expression. I'll wait for you. Okay, we're going to now assume that you've done that and you're back, and we're going to get started. So problem A, we're going to try to factor this in such a way that we can see the terms as we need them, right? So we're going to have the x squared term. First of all, I'm going to rewrite it. X squared plus 8x plus 16. So first off, these are all pluses, so it's going to be an a plus b squared, right? So what are the a terms? We're going to have an x times an x. Well, the x is the one a term we need, okay? We're going to have a plus. I'm not going to finish this yet. And then over here for the b term, it's going to be 16. The square root of 16 is 4. So it's 4 times 4. Well, here's the b term. So we're going to have an x and a 4. So now you go in here, we factor out a 2, and it's going to give us 8 factored out of 2 is going to give us a 4. So it's going to be a 2 times 4x and a 4, right? X, I'm going to put it that way, times 4. Because now you can kind of see how it's going to be broken up when we finally use it. So now it's going to be easy. We're going to say, well, what are the terms? We're going to say this squared. X plus 4. Okay, because here's the x and the 4. X from the a terms, 4 from the b terms, or the a and b is right here inside this parenthesis right here. The x is the a and the 4 is the b. 2ab. Okay, so so now when we complete it, it's the quantity x plus 4 squared. Okay, let's do the next one. Same thing, we're going to look at it. You see that they're both positive, so it's going to be all positives. So we're going to have an n squared plus 16n plus 64. So I'm going to say n times n this is our a term, n squared, n times n. And way over here, I'm going to say 8 times 8 is 64. Here's our b term. There's our a term. In the middle, I'm going to say plus. Can I factor out a 2? Yes, it's an even number. If this was an even number, you might as well stop. You need a different way to factor it. If this is not even, you can't do it. Okay? So now it's going to be an 8 is left, right? An 8 and an n. So it's times, and I'm going to put the n first, times 8, so that it looks like what we want. Here's the 8 from over here, and here's the n from over here. So I'll say, guess what? N plus 8. N plus 8 squared is the factor of n squared plus 16n plus 64. Let's do this last one. Now there's a negative in C. So we're going to do the same thing. N squared minus 16n plus 64. It's the same as the problem we just did, except that it's a negative sign here. So now we're going to do we're going to do the a term, which is n times n. And way over here, I'll do the 8 times the 8 for the b term. Okay, and I can put a plus right there because it's a plus. And now I'm going to look at this and, oh yeah, of course I can factor a 2 out. So I'm going to say minus 2 AB. And what is the A and the, what are the A and the B? The A is the N, and times, what is the B? Is an 8. Okay, so since we can factor it into this form, and we can make this look just like it did, using these terms with the square root of 64, the 8, and the square root of n squared being n, when we can pull a 2 out of this 16, okay, we now know that this is n, oops, sorry, n, I gotta delete, oh, I got an A, I wrote it there, that's weird, n, it's n minus 8 squared. That's it. Okay, example 2, factoring a perfect square trinomial with a not equal to 1. So the first thing I'll do is I'll point out that the a term, not equal to 1, is right here. It's the 9. It's not a 1. The previous example, the a term was a 1. It was just plain x squared. So now we're going to look at this. The area of the square at the right is 9g squared plus 12g plus 4 centimeters squared. Find the length of a side. So here's the problem right here, the trinomial. I'm going to rewrite it. I'm rewriting it right here, and I'm going to factor it. So 9g squared can be factored. It could be taken the square root of, right? So 3 times 3 is 9, and g times g is g squared, so we can take 3g and square it. That's 3g times 3g. We have the 12g, and then 2 or 4 square, the square root of 4 is 2, so 2 times 2, 2 squared is 4. So there's the b term, and here's the a term, the 3g. A term is the 3g, the 2 is the b term. So now we're going to look at that. We see that it's 3g squared, and now we're going to take out the 2 out of the 12g, because you have to be, it has to be even. Take out the 2, and what's left over? 6g. Well, we can factor out a 2 out of the 6g, and we can get a 3g and a 2. So the rule is we have to have a 2, a, b. The a is the 3g, and the 2 right here is the 2 right there. So now we have 3g squared plus 2 times 3g times 2 plus 2 squared. That means that this is a perfect square trinomial. We can now write this as the quantity 3g. We get the 3g from the a term plus the 2. We get the 2 from the b term here. And then we square the whole thing. And that's how it becomes a perfect square trinomial. So the length of the side of each of these sides, if it was given this trinomial as the size, as the size, we can say that the side of a square with length has a length of 3g plus 2 centimeters. So 3g plus 2, 3g plus 2 times 3g plus 2 is going to give you the area of this square, which is 9g squared plus 12g plus 4 centimeters square. And this is centimeters, by the way. cm and cm. Okay? Okay, example 2, check your understanding. Factor each expression. 3 problems. Stop the video. Go ahead and try and work them yourselves. When you come back, we'll do them together. I'll wait. Okay, let's see what we can come up with here. Going to A. Well, A you're going to see is the same as the problem we just had, except the middle term is now a negative. So what does that mean? First, you need to understand this A term up here in the beginning. Everything here has to be able to be factored into a perfect square, right? So the 9 is 3 times 3. The g is g times g. If this is an 8, you wouldn't be able to factor it quite the same, would you? So it wouldn't be a perfect square. So just keep that in mind as we're doing that. So I'm going to go ahead, though. I'm going to write 9g squared minus 12g plus 4. Now, the first term here, I'm going to say this is a parenthesis, 3g squared So now this term is going to be a square. If you square this, you'll get the 9g squared, right? And then over here on the far right, we see that 4 is a perfect square here. It's going to be 2 times 2. So it's going to be the quantity 2 times 2. And now on the inside, we have a negative. Can we pull a 2 out of the 12? Yes, we can. So I'm taking out the 2. What's remaining? 6g. And what do we need? We need a 2g, right? Or what do we need? A 3g. Well, we have that. So 3g times 2. Because 2 times 2 is 4, times 3 is 12. So we just kept breaking it down until we found a 3g to match the A term and a 2 to match the B term. So we have a 2AB, and it's negative. So we're going to write this out. It's going to be 3g, and it's going to be minus 2 square. That's our answer. So now we're going to go to B. See, you see the 4. We can factor. This is 2 times 2, so this is going to work. 81 is 9 times 9. 81 is going to work. So let's go ahead and do it. So I'll rewrite the problem. 4t squared plus 36t plus 81. I'm going to break this 4t squared into 2t, that whole quantity squared. Now this is my A term. And I'm going to go over there to 81, and I'm going to say 9 squared, because 9 times 9 is 81. There's my B term. Now I've got to get, so what do I do here? I've got a 36. Can the 2 come out of a 36? Yeah, it's going to come out nicely. We're going to have a plus 2, and it's going to be 18t. And 8 we need, what do we need for our middle term? We need a 2t and a 9, right? So 18 is 2 times 9. Okay, so we can now get here's the t. We get a 2t and a 9, because 18 is 2 times 9. So these are the terms we needed, and we found we have a 2t and a 9. So that, since we found those, we can now say that the answer to this is 2t plus 9 squared. Excuse me for that. My cough. Okay, let's go to C. Same thing. The 4 can be factored and the t squared can. So I'm going to write it 4t squared minus 36 plus 81. The only difference here is this was plus 36. We're now doing minus 36. So let's see what it is. So it's going to be 2t squared. We know how to do that. 81 is 9 squared. We're going to factor a 2 out of the negative 12. So it's negative 2. And it's going to be, again, 2t and a 9. This time the only difference is going to be, we're going to put on the parentheses, it's going to be 2t minus 9 squared. Okay, objective 2, factoring the difference of two squares. Recall from lesson 9.4 that the quantity a plus b times a minus b is a squared minus b squared. So you can factor the difference of squares as a plus b, a minus b. Okay? So and the rule says the difference of two squares. For every real number a and b, a squared minus b squared is equal to a plus b, the quantity a plus b, times the quantity a minus b. So that's a squared minus b squared. Can be broken down into a plus b and an a minus b. An example of that, x squared minus 81 can be broken into x plus 9 and x minus 9. Minus 9 times positive 9 is negative 81. How about 16x squared minus 49? That is 4x plus 7 and 4x minus 7. The minus 7s multiply together and give you a negative 49, and the 4x's 4x times 4x gives you 16x squared. Okay, example 3, the difference of two squares for a equal to 1. So let's, first of all, here's the problem. It says factor x squared minus 64. Well, obviously x times x is x squared. So there's a square term right there. And 64 is 8 times 8 is 64. So we're already moving in the right direction, aren't we? So I'll write the problem down. X squared minus 64 is equal to x squared minus 8 squared. So now it's all in the squares of all of these, all of the roots of all of these square terms. Okay, we know them. So now, now that we have that and we see that this is true, if we can do this, the answer can be written as x plus 8 times 8x minus 8. And now, because we fit that format. So, and if we want to check ourselves, we can take the x plus 8 times the x minus 8. And we can do x times x is x squared. We can do x times minus 8 is equal to minus 8x. And 8 times x is plus 8x. And the two cancel each other. Here's minus 8x here. And plus 8x, they cancel. And then the negative from this 8 times negative 8 is negative 64. And we're back to our original problem. Okay, example 3, check your understanding, factor each expression, and check your answers. Why don't you go ahead and do them, and when we get back, we'll do them together. Okay, I'm sure you're back, so let's go ahead and give them a shot. Problem A, we can break these down into their factors here. But first I'm going to write out the problem. I'm going to say a squared minus 36. And that is equal to the quantity a squared minus 6 squared. And since we can put it in this form, I can now say that right here that I have a and an a and a negative 6 and a positive 6. That's completed. Now I can check it. A times a is a squared minus 6a minus 6a and a plus 6a and a minus 36. These two terms cancel and I have a squared minus 36. And that's where we started. How about B? M squared minus 100 is equal to m squared minus 10 squared. And from this form, I can say, which is the same as m squared minus 10 squared. Okay, so I can say from here now, I can say the quantities m and an m, negative 10 and a positive 10. That's the solution. To check it, I'm going to say m times m is m squared. M times m is m squared minus 10 times m right here. And the m times positive 10 plus 10. And it's all equal to negative 100. These two cancel out. And it's m squared minus 100. And the very final problem here, p squared minus 49. And that is equal to p squared minus 7 squared, which can be written as p squared minus 7. Oh, I didn't, yeah, 7 squared. Okay, put the parens like this. And now I can break that into its factors, which is a p and a negative 7 and a positive 7. And to check that, I can go right here and I can say p times p is p squared. P times positive 7 is positive p7, or 7p. Negative 7p, negative 7p. And 7 times 7 is negative is negative 49. These two cancel. The answer is p squared minus 49. Okay. Okay, example 4, the difference of two squares for a not equal to 1. And when we say a not equal to 1, we're talking about this right here. The 4 is the a term, is the a coefficient of the x squared term, and it's not equal to 1, it's a 4. And it also is factorable. It's 2 times 2, which is good. It's important. It has to be. And then we also have to have 121 in this case, and it has to be, that's what I meant, it has to be factorable. And 121 is factorable into 11 times 11. So I'm going to rewrite the problem when I write it down, 4x squared minus 121, and I break it into its two terms, that the squared to square. So I can say 2 times x squared is the same as 4, which is 2 times 2, and x squared is x times x. So here I have 2x squared. 2x times 2x is 4x squared. And I also have the 121, which is 11 times 11. I can say it's negative 11 squared. Okay, so now that's in the form we want for the difference of two squares. And since it's the difference of two squares, we can factor this into two parentheses, two binomials, which are 2x and 2x right there, and plus 11 and negative 11. It is now factored, and we're going to check it. Did we do it correctly? We're going to use FOIL. So we're going to take 2x times 2x is 4x squared. 2x times negative 11 is a negative 22x right here. And 2x times a positive 11 is 2211. 22 times x positive. Okay. And then finally we have 11 times 11, it's negative. So it's negative 121. These two terms right here cancel because they're plus and minus the same term. So we end up with 4x squared minus 121. Then that's the solution to that one. Okay, example 4, check your understanding. Factor each expression. Go ahead and pause the video. When you come back, we'll work them together. Okay, now that you're back, I'm sure. Let's go ahead and look at it. Problem A. I see here that 9 and 4 are both factorable into 3 times 3 and 2 times 2. So I'm going to rewrite these. First of all, I'm going to write the problem. 9v squared minus 4 is equal to 3v squared minus 2 squared. And once we've done this, we can now write this as 3v minus 2 times 3v plus 2. Okay? How about B? 25 is 5 times 5. 64 is 8 times 8. 25x squared minus 64 is equal to 5x squared minus 8 squared. And now that can be rewritten into two binomials, 5x minus 8 and 5x plus 8. And how about the very last one here? Problem C. 4 is 2 times 2. 49 is 7 times 7. So 4w squared minus 49. That is equal to 2w squared minus 7 squared. And now that means I can write this according to the rule as 2w minus 7 and 2w plus 7. Okay. Example 5, factoring out a common factor. Some binomials that do not appear to be the difference of squares may have the form n times the quantity a squared minus b squared after a common factor, if the greatest common factor is factored out. So factor, here, let's try one here. It says factor 10x squared, right here, 10x squared minus 40. And remember, this is what we did in section 9.6. Same thing, except the a term was a 1. This time the a term is not a 1. So we've already done one of these. So we're going to factor out, from here we're going to factor out something. And what is it going to be? Well, as I look at it, I can rewrite the problem 10x squared minus 40. And right away know that we can take a 10 out, right? And then we're down to 1. So if we take out the 10, there's nothing else to take out. So here it is, take out a 10. And we're left with x squared and a minus 4. Because 10 comes out of 40 4 times. Okay? So we factored out the greatest common factor. Then once we've done that, we can now factor the x squared minus 4. And we know exactly what to do with that. Because x squared minus 4 is what we said before, right? I can do it over here. It's the quantity x squared minus the quantity 2 squared. We just did those. So now that we know that that's possible, we can write this right here. 10 times x minus 2 times the quantity x plus 2, because that's what this writes out as right here. X minus 2, x plus 2. That's it. No real big difference. Okay, example 5, check your understanding. You know what to do. Factor each expression. Go ahead and do them. Pause the film or the video. When you come back, we will try them together. Okay, you've had time now. You've paused the video, and now we've started it all back up. So let's look. So the first thing we're going to do is what can we factor out of 8 and 50? Does 8 come out of 50? No. 2 comes out of 50. That'll give us a 25. And then a 4 and a 25, that's basically, I think, all we can get out. So I'm going to say, hopefully it works. We're going to find out. I'm going to rewrite this 8y squared minus 50. Okay. And I'm going to say that equals, I'm going to factor out a 2 because I can't get a 4 out of here. So I can't get an 8. So it's going to be 2 times 4y squared minus 25. Well, the 4 is a square. That's 2 times 2 is 4. 25 is 5 times 5. So looks like we've made it. We're going to rewrite this as 2 times the quantity 2y squared minus the quantity 5 squared. And I guess I need to put a parenthesis like that, right? Like that, or a brace or a bracket. Okay, so now that's the 2 stays outside. So that means I have it exactly in the form I want it. I can write this as 2y, okay, and 2y, and minus 5. So it's minus 5 and plus 5. And finally, the 2 is going to stay with it on the outside. So those are the factors. So now let's try B. 3 comes out of 75 25 times. So we're gonna go right with it. We're gonna say 3c squared minus 75 is equal to 3. Factor out the 3. 3 times the quantity c squared minus 25. Okay, now we can break this down into 3 times c minus 5 squared. C squared minus 5 squared. So now I can write this in the term that we want. So we can say 3 times c minus 5 times c plus 5. Okay, and the very last problem is 28k squared minus 7. Well, 7 comes out of 28 4 times. So we're going to take out a 7 out of the 28. So I'm going to rewrite it. 28k squared minus 7. And that equals, I'm going to take out a 7. 7 times 4k squared minus 1. Okay, so now we have this k squared here. So this can be broken down again. We're going to say 7 times 2k squared minus 1 squared if you want. We can do that, right? And now if I break that apart, it's going to be looking like this. It's going to be 7 times 2k minus 1, and 2k plus 1. Okay, good job, everyone. I think that's the end of this.